We download the program CropET from the web page that is included in the web page of Fitotecnia, the web page of the University of Córdoba. Click on the version that you want to download and it will download a single file. Then we copy this single file from the download folder to a new folder that we have created called CropET or whatever other name you may want. Then to start the program you double click on CropET. Then it will advise that it is signed by Universidad de Córdoba and then you click on Run. There we go. That starts the program that first opens this form related to the selection of crops for the crop rotation. For instance, let's choose a crop of maize, grain maize. We click here Add. If we were to use a southern latitude, we should click this first before adding any crops. Now we see different options for cycles of maize. Let's assume that the one that we want is M, means Mediterranean climate, with start month March or April. These crop durations for the 4 stages of the FAO method, total duration of 160 days. Click on select and then use selected option. That suggests a starting day of year. We can use, for instance, day 90. This is around April the 1st, and these are the durations that we have already seen: maximum crop coefficient and final crop coefficient. The maximum ground cover is assumed to be 100%, and the price of the harvest is going to be $200 per ton. We can edit any of these values. Click on proceed, and with that we go to this form where the calculation of evapotranspiration of the crop is performed. Here we see what are the weather files that we have in folder weather. We have only one file at this moment, and is Córdoba Aeropuerto. This is Córdoba in Spain, and GEN means that this is generated weather data. Click on this file and it will automatically fill the latitude and the altitude if the file is already in the folder Mon files. If we can refill the soil with winter rainfall, click here to use the store soil water during the growing season and choose the type of soil that you want. Let's stay at loam soil, and now we click on calculate and the program provides the potential yield and the expected yield. We assume that the expected yield is equal to 75% of the potential yield. This is the seasonal evapotranspiration, this is the seasonal reference evapotranspiration, this is the effective rainfall, and this is the crop water requirement for the whole season. The potential yield is calculated as a function of intercepted radiation. In any case, these are only suggested values, and we can always put here the value that we want. In the folder where the program is located, there are several files that will be generated. There is a file called results.txt that we will see later, but in relation with evapotranspiration and crop water requirements, there are 4 CSV files. These are text files with comma as separator, and one is the time course of ETO throughout the year. It is out ETO. The second is out year, that includes annual values of the different variables, and the distribution functions of rainfall and crop water requirement. Let's see, for instance, the evapotranspiration, the reference evapotranspiration for the different weeks of the year. In this file, ETO out ETO, we see for the different weeks the value of ETO in millimeters per day and the standard deviation. This is the value that corresponds to the 30 years that we have used for the calculation. In file out year, we see the values for the different years of ETO, ET, effective rainfall, crop water requirement, and expected yield. This is the grain maize. Look that it will only calculate the number of years is equal to the total number of years minus 1. So we have 30 years of the data and the program will only use 29. This is done to make room for crops that go through 2 consecutive years. In file out this function rain, we have the distribution functions of weekly rainfall. For instance, for the first week of the year, we have these different values of rainfall according to the level of probability. For instance, in 90% of the years, rainfall will be equal or lower than 43 millimeters. In 10% of the years, rainfall will be 2 millimeters or less. The same goes for the out this function CWR, crop water requirement, and number 1. Number 1 refers to the first crop in the rotation. If we only have one crop in the rotation, we will only want a file name with a 1. If we have several, we will have different values here, 1, 2, 3, etc. And here, for each week of the year, we have the distribution function, the values of crop water requirement for different probability levels. For instance, in the week from the June the 10th to June the 16th, the crop water requirement will be 48 or less in 90% of the years.